Hey everybody. Today we're constructing beautiful probability histograms in R using the qplot command. We're just going to run through a couple of examples. In this first one, we have a discrete random variable x that can take values from 1 to 6, and I've listed the probabilities for those different values here. So let's switch over to R, input the data, and generate the histogram. So first of all, we want to input the variable x. Here, it can take values from 1 to 6. So let's do that. Let's use the abbreviated colon operator, 1 to 6. So now x is 1, 2, 3, 4, 5, 6. Now let's create a vector of the corresponding probabilities. So in this case, the probabilities for the values 1, 2, 3, 4, 5, and 6 are 0.15, 0.1, 0.1, 0.4, 0.2, and 0.05, respectively. Order matters here. The probabilities have to go in the same order as the values to which they correspond. Let's do a quick check to make sure that we inputted everything correctly by taking the sum of all those probabilities. Here we get 1. That should always be the case. If we have a legitimate discrete probability distribution, the sum of all the probabilities should always be 1. So that's a good sign that I input the data correctly. All right, let's actually generate the probability histogram. We want to do qplot, and we want the x values to go along the horizontal axis. Next, we want to let R know how to weight them. So each of those x values will have a height determined by p. Finally, we want to let R know how to actually display the data, and in this case, it's a histogram, and it does have to be spelled correctly. Okay, so here's a histogram in the lower right. It's not exactly what we're looking for yet. In particular, right now, we have a lot of space between these vertical bars. In a probability histogram, adjacent values should have bars that touch one another, that butt right up against each other. So let's fix that. Here we have 6 different values. They're all adjacent to one another. So let's ask R just to use 6 bins. Now we're getting something that's starting to look a little bit more like a histogram as we know it. Let's do one more thing on this one. Let's make these bars look distinct from one another. So let's add some boundary color. And I will just use black in this instance. I equals parenthesis quote black. That's just letting R know to use a boundary color of black for all of these bars. In the second example, I'll do some additional things to make the histogram look even better. Here's the second example we're going to do. This time we have a random variable y that can take on 5 values, 15, 16, 18, 19, 20, with the probabilities that I've listed here. Notice in this case there is no probability for 17. 17 is not a value that can be an outcome for this random variable. Okay. We're going to follow the same process, so let's let y be 15, 16, 18, 19, 20. And we'll stick with p for probability. 0.14, 0.12, 0.21, 0.3, and 0.23. And now we're ready to do our qplot. Again, we take the the variable that we're interested in. That's going to go on the horizontal axis. Then we set a weight argument to be equal to those probabilities and let R know that we want to do a histogram. Again, with what I have typed so far, I know I'm going to get these skinny separated bars, which are not exactly what I want, but I'm going to start with that anyway this time, because here it brings out an important phenomenon. Namely, we can see that we have an empty bucket at y equals 17. We can see some space between 16 and 18. That's desirable. We want our plot to capture the fact that the probability that y is 17 is 0. If we were to blindly say, use 5 bins, that fact will be obscured. Here, there are only 5 possible values, but there's a blank one in between some of those that we want to omit. This plot makes it look, or at least suggests, like there's probability that y could be equal to 17. So I actually want to use 6 bins so that I have an empty one there at y equals 17. This is looking a bit more like a histogram that we would want. Let's just make it a little bit prettier. So this time, let's take a boundary color of, I don't know, let's say dark blue. And let's get a fill in there. Let's put an inside color. And let's just use regular blue for that one. One other thing that we might want to do is to change some labels. So how about a y-lab? And in this case, the y-axis is labeling probabilities. So let's put that in there. Finally, we may as well change an x-lab while we're at it. This is a rather abstract data set, so let's just say values. Okay, so that's starting to look just a little bit more professional. Obviously, we can tinker around with the colors and the labels to make this look even better. And that's how you do an elegant probability histogram in R.